We're now going to talk about research studies. So a research study is a statistical study that you use to determine the relationship between variables. Okay? So this is used to determine relationships between variables. So remember, a variable is something that varies from observation to observation in the population, and you collect data by observing the value of a variable. And so in a research study, you're wanting to learn if some sort of relationship actually exists between the two variables. And so there's going to be two types of research studies that we're going to look at. So the first type is observational studies. And the second type is experimental studies. Oops. And what I'm going to do, instead of writing out a definition, I'm going to give you an example of each of these. But basically, the observational study is where you're just observing the value of a variable, of two variables, to see if a relationship exists. And oftentimes the observational studies are called correlation studies. And it's important to realize that correlation does not show causation. That's a famous maxim in statistics. Just because there's a correlation or a relationship between two variables, that doesn't mean that it's a cause and effect relationship. So if you want to show a cause and effect relationship, then you actually need to set up and perform an experimental study, some sort of experiment that can actually show that the relationship is a cause and effect relationship. Okay? So let me give you an example of an observational study. Okay, so a researcher is wanting to know if a relationship exists between the number of hours that someone works at a job, let's say outside of class, and their grade point average. Okay, so in this case, the researcher randomly selected 5 college students, and it asked each college student how many hours they worked, and it asked them their grade point average. So from each observation in the sample, they collected 2 pieces of data. So they actually call this bivariate data. Bivariate, like a bicycle has 2 tires. Bivariate data has 2 variables. They're looking at 2 variables. And these kind of form an ordered pair. And we're going to see in Chapter 2 that you can make a scatter plot. This is like the x-coordinate, this is the y-coordinate, and you can plot the data by plotting ordered pairs in the plane. Okay? But even putting it in a table like this, so they took the number of hours that they work per week, and they arranged those from the least to the greatest. And these are their corresponding grade point average. And so what you can see, as the number of hours that they work goes up, the grade point average goes down. So what we would say is that there seems to be a negative correlation between the 2 variables. What that means is that as one variable goes up, the other variable goes down. That's a negative correlation. So now that's what we're doing. We're just observing the value of the variable to see if a relationship exists. Okay? Now, it's tempting to say, oh, that must be a cause and effect relationship. Okay? Because if we increase the number of hours they work, we see that the grade point average goes down. But it's very important to realize that correlation does not prove cause and effect relationships. Correlation does not prove causation, is often what you hear. And in this case, it's it might be a little hard to see that. And the reason for that is it could very well be a cause and effect relationship. We just don't know that. Okay, just by observing the values of the variable, all you notice is that some relationship exists, but there's lots of different reasons that there could be a relationship between two variables. Doesn't have to be cause and effect necessarily. Okay, so here's an example to help you see that. Okay, so this is a researcher that would like to know, is there a relationship between churches and violent crimes? So they do a study. They take a random sample of 5 cities, and they count both the number of churches and the average number of violent crimes per week. And what they notice is, as the number of churches increase, the number of violent crimes also goes up. So there's a positive correlation. So this is a negative correlation. This is a positive correlation, and that means as one increases, the other one also increases. They go together. They go up together. Okay? So now this researcher here, what would you think if he turned around and then published the results of his study and he claimed that churches cause violent crimes? Okay? In this case, you know that's a mistake, and the reason you know that is because you actually understand what the relationship is that's causing the positive correlation. And that relationship is, as the size of a city increases, then there's going to be an increase in both the number of churches that the city has and the number of violent crimes per week. Okay? So the relationship here does indeed produce a correlation. It does produce a relationship between the two variables, but that relationship is not a cause and effect relationship. And in the second case, it's obvious. Now, in the first case, it's not so obvious. Okay? So it could be that as you increase the number of hours someone works, the grade point average goes down. We might even, in our minds, think, yeah, if they work more per week, they don't have as much time to study. So we can maybe even see kind of what the relationship might be, if there is a relationship. Okay? But to get evidence that the relationship here is a cause and effect relationship, a correlation study is not going to provide that kind of evidence. So to get evidence for a cause and effect relationship, you need an experimental study. So now let's look at an example of an experimental study. Okay? So in this case, this is the same example. The researcher wants to know, in this case, does the amount of hours someone works per week, does that affect, or does that cause, does it have an effect on the grade point average? And in particular, does that cause the grade point average to go down? So in order to get evidence that, yes, there is a cause and effect relationship, what they need to do is set up an experiment where there's 2 treatment groups, and they're going to randomly divide it. So in this case, they take a sample of 10 college students, and they randomly divide those college students between the 2 groups. And in one group, these are going to be students who work 10 hours per week, let's say. And then in the other group, these are going to be students that work 40 hours per week. So in this case, they actually have to set up, they got to control the schedule of these college students. And they tell these college students, you can only work 10 hours per week, and you guys can only work 40 hours per week. You must work 40 hours, you must work 10 hours. And then what they try to do here is they try to keep everything the same between the 2 groups that would affect their grade point average. Anything that would affect the grade point average, they keep the same between the groups except for the number of hours that they work. Okay, and then the logic here is if they're able to keep everything the same and the only thing that's different is the number of hours they work, then if there's a significant difference in their grade point averages, in a sense you can kind of, quote, blame that on the number of hours they work because you kept everything else the same. Okay, so some of the things that might have an effect on their grade point average would be the classes they take, the time of day that they have the class, the instructors that they take, maybe the job they have, how stressful it is, whether it takes their mind off school, their diet, if they think maybe the food that they eat affects, or the amount of sleep that they get at night. So all these things they try to control and keep the same between the two groups. So they might have a job that everyone works, like a McDonald's or something like that, and everyone does the same job. They take the same teachers, the same classes. They have to eat the same food. They have to go to bed at the same time. Anything that they think would affect the grade point average, other than the number of hours that they work, they keep the same between the groups. And then at the end, they compare these, and it does look that these are significantly lower than these. But these two will not necessarily be the same. There's going to be some difference between them due to just sampling error. Okay, so where the statistics comes in is there's statistical formulas where you put in this data and you compare, you put it into a calculation and you calculate, like they call it a test statistic, and you compare it to a number on a table, and that's going to tell you if the difference is significant enough, if it's statistically significant. So that that would mean if the difference is statistically significant, then you have enough evidence to conclude that the difference is due to the change in the number of hours that they work. So that's the idea, okay? So the independent variable, there's an independent variable, dependent variable, and confounding variables in an experimental study. So the independent variable is the variable that you want to show as the cause. So in this case, it's the number of hours that they work per week. So the independent variable is the variable up here at the top, if you diagram the study in this way. Okay, so it's this variable that you manipulate, the number of hours that they work. Okay, and it's the thing you want to show as the cause. The dependent variable is the thing that you want to show as the effect. So in this case, it's the grade point averages. It's the measurement that you're going to compare at the end of the study to see if there's a difference between the two groups. So the independent variable is the cause, in this case the hours that they work. Dependent variable is the effect, which is their grade point averages. But then there's also confounding variables. This is any variable other than the independent variable that might have an effect on the dependent variable. Okay, so what that means is it's anything that might affect the grade point averages other than the number of hours that they work. Okay, so it could be the class difficulty, the teachers, textbook used, amount of sleep, whatever it is that might affect their grade point average other than the independent variable. Okay, and what you try to do is you try to keep these to a minimum. You try to control these so that they don't, in a sense, confound your experiment. That's why they're called confounding variables. One thing about an experimental study, if there is a significant difference, we would say that provides evidence that for a cause and effect relationship, but we wouldn't say that it proves that there is a cause and effect relationship. And the reason for that is that you can't control all confounding variables. There's going to be some confounding variables that you're not going to be able to control. There could even be some confounding variables that you are not even aware of, so you wouldn't even know that you had to control them. The interesting thing is there could even be some confounding variables. So there could be some confounding variables that we as human beings don't even have the ability to be aware of. We're not even able, we don't have the faculties to even know what they are or to understand them. I mean, we just don't know. Okay, so we would never say that we have a of a cause and effect relationship. We would just say that there's evidence for a cause and effect relationship. So one confounding variable that's kind of interesting is that when you're dealing with people, their mental states can have an effect on the dependent variable. So, like if you, let's say you divide people into two groups, you know, I don't know what the group, you know, maybe it's, you want to know, does taking in caffeine, does that cause the amount of sleep you get to go down? Something like that. Well, maybe if the people realize, oh, I'm in the caffeine group, you know, I'm not gonna be able to sleep. And just their mental state might keep them awake at night, just knowing that they're in the caffeine group. And so, one way that they keep that to a minimum is that they give people placebos. So they might tell both groups not to take in any caffeine, and then they give one group a pill, the other group a placebo. And a placebo is like a sugar pill that doesn't have any caffeine or doesn't have any effect. And so then they don't know whether they're in the caffeine group or not. And so that eliminates the worry that they have that might affect the amount of sleep. And oftentimes maybe they just give each person a pill, and they don't even tell them what they're studying. They don't even tell them it's a study about caffeine. And so that's called a blind experiment, where the subjects are blind. They don't know what's going on. And oftentimes they do a double-blind experiment where the researchers don't know what's being tested. They're just told what to do and the observations to get, but they're not told why, because sometimes the researchers' state of mind can affect how they measure the variable. If it's maybe self-esteem or something, and it's supposed to be some medicine that helps people's self-esteem, well, that might, they might think, oh, I'm now interviewing the group that took the medicine. And so when they judge whether or not it had an effect on their self-esteem, then it, that might affect how they judge the group's self-esteem. So, okay. So this is the idea of an experimental study. So, let's do an activity now. And let's see if I can get all 4 of these in here. And so what I'm going to do, maybe if I can, there we go, is I'm going to have you pause the video. And then what you're going to do is you're going to determine for each of these whether it's an observational study or an experimental study. So for the ones that are an experimental study, I want you to determine the independent variable, the dependent variable, and then even maybe list some of the possible confounding variables. So go ahead, hit pause, and then start it back up again. We'll see how you did. Okay, so let's go ahead. We're going to look at each of these. So this first one, a sample of 100 adults is selected. 50 are allowed to exercise for 1 week, and the other 50 are put on a 50 are not allowed to exercise for 1 week, and the other 50 are put on a strict exercise regime. Their blood pressures are compared at the end of the week. So this is the example of a experimental study, okay? And the reason is they got the 2 groups. One is not studying, one is not exercising, the other one must exercise for a certain amount of time. And then at the end of the study, they're getting, in this case, blood pressure scores to see if maybe the exercise had an effect on their blood pressure. So this is an experimental study. You're not just observing the values of the variable, but you're setting up an experiment and comparing these blood pressures at the end. Okay, so the independent variable is the thing that you want to show as the cause. So it's whether whether they exercise or not. So it's the exercise. The dependent variable is the thing you want to show as the effect. So that's going to be the blood pressures. Okay, so any confounding variables, well, this could be the amount of food or the type of food that they eat, the amount of sleep, maybe their stress level at work or at home, anything that might affect their blood pressures other than the amount of exercise they get. Okay, so this second one, a researcher randomly selects 500 college students. It is discovered that in general, as their alcohol consumption increased, their grade point average went down. So this is an example of a correlation study or an observational study. They're just observing two variables, in this case their alcohol consumption, their grade point average, and they're checking to see if a relationship exists between the two variables. So this third one, a researcher randomly selects 50 menu items from fast food restaurants and records the number of calories for each meal and the price of the meal. And it's determined that no relationship exists between the variables. Again, this is an observational study. They're looking for each of these menu items. They're looking at two variables. They're looking at the number of calories, and they're looking at the price, and they're checking to see if maybe as one increases, the other one increases, or vice versa. And in this case, they don't see any sort of relationship. So that, again, is an example of a correlation study. So this last one here, to see if a new antidepressant is effective, a researcher randomly selects a sample of 50 patients who have been diagnosed with clinical depression. For 6 months, half are given a medication and half are given a placebo. They are assessed by psychologists both before and after to see if their depression has improved. So this is an example of an experimental study, and they're wanting to show, does the medicine have an effect on their depression? So the medicine, whether they get the medicine or the placebo, that's the independent variable. And then whatever assessment score the psychologist gives them, that's the amount of depression in a sense. That's the dependent variable. The thing they want to show is the effect. And then there's different confounding variables. It could be the food they eat or the movies they watch, home life, other things that could affect the depression other than the medicine. And so those would be the confounding variables. This is a good example where the placebo is getting rid of the person's mental state. They might think, oh, I'm taking this medicine and it's supposed to help, and that just, it might not be the medicine, it might just be the thought that they're taking the medicine that makes them feel less depressed. Okay? And so this would be a good example to have the placebo. Also, these psychologists that are assessing the amount of depression in the people, it would be a good idea to have these be psychologists that you're just asking, I'm doing a study, and why don't you assess the amount of depression in each of these subjects? But you're not telling those psychologists, like, these are the subjects that take the medicine, these are the ones that don't, or even whether this has to do with medicine. You're just asking them to assess, because you don't want their state of mind. You don't want them to think, oh, I'm assessing those that are taking this medicine, so they must not be as depressed, because that could have an effect on what sort of score they give the people. Okay. So that's the idea of research studies, and so you're just determining whether it's an observational study or an experimental study. And then with the experimental study, there's independent and dependent variables. Okay, so technically in an observational study, those don't. An observational study isn't necessarily going to have an independent or a dependent variable. Those are just for the experimental studies. So with the homework, you'll determine whether it's observational and experimental, and then there's problems where they give you an experimental study, and you're going to determine what the independent and dependent variables are.